7 statistics. We are going to be discussing sampling distributions. This is day 1, and the first one is called, the activity is called Average on Chapter 6 Test. Okay, so the first thing that we're going to do is go ahead and get the averages of these tests. So basically, we're taking a small population. That we're going to say it's a small school, maybe a small private school, and there's only 5 people in this particular class. And the scores on the test were 60, 70, 80, 90, and 100. So that's the entire population. Okay, if I took a random sample of 2 of the scores, let's say I randomly chose number 70 and 90, put them all in a basket and pulled 2 of them out. The average of that score is 80. So now what we're going to do is I'm going to give you all the combinations of pulling 2 scores out of that hat. And you can see under number 2, those are all the different combinations. And then I found the average of each of those. So for the first one, 60 and 70, the average is 65. For 60 and 80, the average is 70, and so forth and so on. So then we went ahead and graphed those, but I want you to understand each dot represents the average of my 2 samples that I pulled. So for 65, for instance, this dot here, that is the average of 60 and 70, and so forth and so on. So the mean of the score of all 5 students, if I actually found it, it would be 80. So then we're going to do the same thing here, but now a bigger pool. Now this has 40 students. So what I'd like you to do is take a random sample of 5 scores. So I took a random sample of 5 scores. And so for instance, this one here, the first one that I chose, what I did is I did a rand int in my calculator. So rand int in your calculator. And I did 1, 40. And I hit enter and I did it 5 times until I got the different scores. And so for that first one, for instance, my first one was 13 and the corresponding score was 85. The next one I got was number 10 and this corresponding score was 67. The next one I got was 13 again, but I already got 13, so I'm skipping it. After that, I got number 26 and that's 90. And then I got number 36 and that's 73. Then I got a 10 again, and so I'm skipping a 10 because I already got a 10. And then finally I got a 12 and that's 70. So that's all 5, and I found the average, and the average was 77 of those 5, just adding them up and dividing. So then what I did is this was my score was 77, so which is right here. And then I asked every single person in the class to do the same thing. And then we graphed it, and this is the graph that we got. Remember, each dot represents the average of 5 test scores. So the average of all 40 students, if you put them in the calculator, you get 82.1. But you can see my average, which I'm right around this area kind of too, is pretty close to my actual average. And that's kind of what we want to get. So what we have is the statistics are all of these things here. See, the statistics is everything, all the things that I was able to, this is a statistic because I was able to calculate it from my sample. Anything that I calculated from my sample, this is a statistic. The sample mean is a statistic. Anything that I calculated from my sample. The population mean, that is a parameter because the parameter comes from my population. So you can see the difference. So sampling distribution is exactly what we just did. The sampling distribution was this graph here, right here. This is sampling distribution. And each dot represented, for ours, 5 different scores per dot. An average of 5, the average of what is of 5 scores. We're going to count the dots, and if it's less than 5%, it's considered statistically significant. So for instance, if I said, is it considered unusual to have a 90 or above? Well, I would do this, and I'd say 90 or above, 1, and I have 30 dots, so 1 out of 30 is definitely, it's about 3%, and that is less than about 5%. And so since it's less than 5%, then yes, I would consider it statistically significant. Okay, go ahead and let's identify the population parameter, sample, and statistic for number 1. So the population, remember, it's what I am actually studying. And so when you read it, you can see that I'm actually studying the population of the temperatures for the 24-hour period. The parameters that I'm going to be doing is the standard deviation, Or you could have the mean as well. Those are also the parameters. Any of my Greek letters represent the population. So that's the true standard deviation. The sample is the simple random sample of 10 times because it tells me right here of n is 10. And the statistic is my sample standard deviation, which is S. And that's the 5. This asks, would it be unusual to get a sample standard deviation of 5 degrees or greater? Well, if I go to 5 degrees or greater, if you can see, there's no data over here. So 0 out of all of this is obviously less than 5%, and that's what I'm trying to find out. So is there convincing evidence? Yes, there's convincing evidence because I'm saying it's unlikely that this happens by chance. And so we are very convinced because I have a very low percentage that says that that happened by chance. And I think that we're going to have more variability in the thermometer than in the manufacturer claims. All right, I hope that helps. Thank you so much.